what would you think if I told you that after taking a few measurements of my daughter's height and calculating the average, I reported her height as 139.7834 centimetres tall? Now hopefully you'd pause and think it really doesn't make much sense to report someone's height to within a micrometre. That's less than the width of a hair. Now if you did come to that conclusion, you would be demonstrating that you understand there's no point in reporting too many digits of precision in a quantity. You should only use as many numbers as is relevant to the level of uncertainty in your quantity. And this concept is referred to as the number of significant figures. The number of significant figures in a quantity is simply the number of digits that are meaningful. It's related to the precision of your measurement. And it's a useful bit of scientific jargon that helps when estimating quantities and errors, and it's best explained with some examples. So here are some numbers I've written down. First of all, any zeros at the start of a number are not counted. That's because they don't contribute to the magnitude of the quantity. So 0.007 has just one significant figure. After the first non-zero, all subsequent digits are significant. So 0.107 has 3 significant figures, and 2300.1 has 5 significant figures. Now, all zeros to the right of a decimal place are significant. So, for example, 6.300 has 4 significant figures, and that's because you're specifying that the value is 6.300 and not 6.301. Now, there's always a bit of ambiguity when you have large integer numbers. So if I write down 57,000, then it's not clear whether I mean 2 significant figures here or whether I mean there's a full 5 significant figures. So this relates to quantifying your uncertainty. So I'm not sure, is this plus or minus 100, say, or is it plus or minus a half? So if it was plus or minus 100, then I've got, say, 2 or 3 significant figures. But if it was plus or minus 0.5, then I would be having 5 significant figures. So one way to get around this ambiguity is to specify the uncertainty, as I just did. And another way is to use what's called scientific notation or standard form. So I can write 57,000 as 5.7 times 10 to the power of 4. And if I write it like that, then I know there are only 2 significant figures here. But if I was to write it like this, then all those zeros that I've specifically written down after the decimal point, these ones count as significant. So this is 2 sig figs again, and this is 5. One more thing I need to say about significant figures is that errors or uncertainties are only ever given with one significant figure. And the measurement that has this uncertainty should have no digits in decimal places smaller than that uncertainty. So in our examples here, the first one is a good measurement, but the second one is not acceptable. In the second example, you have to round off the last digit. Now remember my example at the beginning of the video. I said I measured my daughter's height as 139.7824 centimetres. But the uncertainty in this height measurement is really much more like 0.1 centimetre, so it really only makes sense to write 139.8 plus or minus 0.1 centimetres.